Before talking about the function of the nephron, I need to orient you to the shape and location of the nephron in a kidney. I'm going to take a mammalian kidney and move it onto its side. So there'd be a ureter leaving. This is the tube that is taking urine away to the bladder. You'd have arterial blood coming in and venous blood leaving. The nephrons would start with Bowman's capsule, have a convoluted, proximal convoluted tubule, loop of Henle descending down in, ascending loop of Henle, bring it back up, and collecting duct. So if I label these parts, here's Bowman's capsule, and then the proximal convoluted tubule, the descending loop of Henle, the ascending loop of Henle, the distal convoluted tubule, and the collecting duct. And for the loop of Henle, there's the descending and ascending portion. So if we looked throughout the kidney, you'd find a whole series of these in which the loop of Henle goes down and proximal convoluted tubule, descending loop of Henle, ascending loop of Henle, distal convoluted tubule, and collecting duct. So again, if I color these, we get Bowman's capsule, the proximal convoluted tubule, descending loop of Henle, ascending loop of Henle, distal convoluted tubule, and collecting duct. So all of the material from the collecting duct, that's the urine that's going to be going out through the ureter. The other thing I want you to pay attention to here is the concentrations. So around the margins here, the concentrations are about 300 milliosmoles. That's about the same concentration of ions and salts and glucose and everything else in the rest of your body, in your cells and your extracellular fluid. So around the margins here, in what's called the cortex, it's around 300. And depending on the mammal, it's different deep in the medulla. In a human, it gets to somewhere around 1400. And later we'll talk about why that's that way. And in between, there'd be, of course, intermediate concentrations. Okay, so this is the background you need before we go on to talk about the nephron.